All right,
right.
welcome everybody. My name is Chris and I work here at Zillis, and today I'm your host for this session with Eugen. Eugen is one of our extraordinary developer advocates. And so Eugen, I'll let you take it away. Before you do, just remind everybody the session is being recorded, so you can take a listen to it later on and we'll send you the links. Please put your questions in the chat or the Q&A. And or have your little AI agents just take notes, whatever you like. All right, take it away.
All right. Thanks for that intro, Chris. Hello, everybody. Today we're going to be talking about how you can do RAG without OpenAI. And in particular, we're talking about how to do RAG with Milvus, Mixtral, OctoAI, and LangChain. And this is a little bit about me. My name is Eugen Tang. I'm a senior developer advocate here at Zillis. That QR code there on your right-hand side will take you to my LinkedIn page where you can follow me to keep up with all of the AI things that I post. And a little bit about my background. I've been in AI ML for a while. I've been in software since 2013. I published my first ML papers back in 2017, 2018. And I worked on AutoML at Amazon before I got into startups and doing developer advocacy. I found that I really enjoy writing papers, making videos, and giving talks like this. So let's get into what we're going to talk about today. So first, I'm just going to do a brief overview of what we're going to talk about and what we're going to build. And then I'm going to talk about the different pieces of the tech stack that we're going to cover. So we're going to talk about Milvus, which is an open source vector database. It's the only open source distributed vector database. And then we're going to talk about Mixtral, which is one of the more recent models from Mistral. And then we're going to talk about OctoAI, which is our LLM provider that we're using to access Mixtral. And then we're going to talk about LangChain, which, unless you've been living under a rock, you probably know about LangChain. And then we're going to go into a demo. I'm going to do a code demo at the end. So be prepared, have your VS Code ready, and just know that we're going to walk through some code. You don't have to do all the code as I do it, but it'll probably be helpful for you to at least have something up so you can follow along. Okay, so let's do the overview first. The tech stack that we're going to be covering today is we're going to be covering Milvus, and then we're going to use Mixtral via OctoAI, and we're going to use LangChain. So Milvus is our vector database, right? So our vector database is a database that lets you interact with, analyze, use basically unstructured data that you weren't able to use before. And essentially what we're doing is we're quantifying qualitative data using vector embeddings. And then for the LLM piece of the RAG app, the LLM is kind of your core piece. It's one of the shining pieces of RAG. We're going to be using Mixtral, which was developed by Mistral AI, and we're going to be using that through OctoAI. And OctoAI is actually based here in Seattle, where I'm based. And I would love to know where you guys are based as well. If you would like to drop something in the chat, just telling me where you're from. And then to orchestrate everything, we're going to be using LangChain. So LangChain is a framework for generative AI that's really, really built on how you can orchestrate and put together a bunch of pieces to build RAG. Oh, I see there's someone from SF. Okay. West Coast, very much West Coast. This is generative AI is something that is very popular here on the West Coast, so that makes sense. Oh, someone's in France. Hey, oh, awesome. Okay, Toronto, Cincinnati. Oh, wow, that's surprising. India, New York. Okay, I see we have a very, very diverse audience here. Washington, D.C. More of the Bay. This is great. San Jose, yes. Okay, Connecticut, Mexico. Wow. Okay, super cool. What a diverse audience. More Paris people. You guys are gonna have to talk to the Mistral people, okay? You guys who are in Paris, you guys gotta talk to the Mistral people for me. Okay, so what is RAG, right? Let's take a look at what this architecture looks like. So this is a very, very simplified architecture. This isn't obviously like this isn't the everything that's going to be built, but essentially the idea behind RAG is you're going to take your data and you're going to embed it. And so I've missed the embedding piece, but you're going to embed it via some sort of embedding model. And then you're going to put that into Milvus as your vector database, right? So your data goes into a vector database like Milvus. And then Milvus is going to sit there and it's going to be your, let's say, source of truth. And your LLM, in this case, provided by Octo AI, is going to talk to your vector database. And then when you have a question at query time, you're going to ask that question to the LLM, and the LLM is going to say, okay, like, here's the question. Now I need to know, how do I get the answer to this? And so what it will do is it will execute some sort of semantic search. And the way it executes semantic search is it gives the vector database, in this case, Milvus, what it needs to search for. And Milvus will do a search for that and return the top XYZ results, top 5, top 3, top 10, whatever. And then the LLM will take that as the context and it will answer that question and it will give you a response. And you see that I've got the LangChain logo here. And so LangChain is what we're going to be using to execute or to orchestrate all of this kind of, back and forth between you, your data, the vector database, and the LLM. Oh, I also see that we have someone from Slovenia. Wow, very cool. So let's take a look into these pieces of the tech stack. So first thing we're going to look at is Milvus. Don't be afraid. I know this is a very complicated looking architecture diagram, but I'm going to walk you through all the pieces you need to know. You don't need to know the entire diagram to understand what's going on. So the first thing to know is kind of like, what are the pieces here? What is this? What is being done underneath the surface, right? And so what's being done underneath the surface is there are these 3 different separations of concern when it comes to doing any kind of search. And in this case, we're doing vector search. And so these separations of concern are querying, which is basically how do I find my data? Data, which is how do I get my data in? And you can also think of querying as how do I get my data out? And then indexing, which is how do I build the map of how I'm going to find my data? And indexing is something that, it is in every kind of database, but it's particularly important for vector search because vector search is very, very computationally expensive, right? So we're going to cover kind of what vector search looks like in a moment. But the idea behind vector search is that you're comparing these long lists of numbers and you're trying to find the ones that are the closest. So these nodes are separate in Milvus because they need to be scaled separately. You will never be in a situation, well, maybe I won't say never, but it is very unlikely that you will be in a situation where you're going to be doing like millions of queries and also building millions of indexes at the same time. And on top of this, each of these, as your data comes in, indexes are built on segments of data as they come in. So why is that, right? So if you think about it, an index is basically a map of your data. And so if you put a bunch of data in at once, and then you build a map on it, that's great. But what happens if you need to grow that data, if you need to shrink that data, or if you need to start replacing some of that data, right? So we have a dynamic way to build indexes using Milvus. And so that's kind of, that's the idea behind these segments. And it's also much more scalable. If you think about, let's say, hundreds of gigabytes of data, it's much more, it's a much lower big O to parallel search a few segments in parallel as opposed to searching the entire thing linearly. And then the last thing that's kind of interesting that you might want to know about this is basically the way the data gets put in is modeled as a pub sub system. So data comes in and the message store area basically publishes this data, and the query node and the data node will subscribe to the message store to keep track of the data that's coming in. And the data node will basically be like, okay, now enough data has come in, there's a segment, we need to flush it, tell the coordinator to call the index node to build a segment. So that's the basic idea behind Milvus. And now let's take a look at what some of this data looks like so we have a better understanding of what's going on. So this is what an entry into Milvus or will look like. So this is, I took this from Zillis, but essentially you need these top 2 entries, the ID and the embedding. The ID is the way that we find your data, like the exact data point that you want. That's how you can do deletes and upserts. And then the embedding is the way that you can compare data, right? So earlier I said what vector databases like Milvus do is they allow you to do this kind of quantitative comparison of qualitative data. And so that's what the embedding's for. And that's why what you see there is just this huge list of numbers. And the rest of this is what we call metadata. So metadata is data that you want to store along with your ID or your embedding. And this data helps you either define what, what kind of data you stored. Perhaps it is the sentence, right? In this case, we've got paragraph. Perhaps it's a sentence that's being embedded, or the chunk of text being embedded. We've also got a date. Maybe you want to know when it was published. We've also got the publication, who published it. So these are pieces of the vector data that you would store into Milvus. And remember, the most important pieces here, these two pieces that are the most important for you to know, are the ID and the embedding. And everything else is metadata that is optional. Okay, so now that we've talked about this idea of quantifying qualitative data, let's take a look at how that actually works. So this is very much a toy example. Okay, let's preface this that you're never going to see people using two-dimensional vectors, right? So in this case, these have two numbers that represent a word. That means that word is represented in 2 dimensions in this case. You're never going to have two-dimensional data in production. The main thing that you're going to do and you'll also never do Manhattan distance, which is what I'm about to show you in production. But the main thing that I want you to take away from this slide is that vector embeddings allow you to do math on words or math on things that were not originally numbers. And before we get into that math, there's one other thing I have to point out here. This is really, really critical that you understand this, okay? So you'll see that queen and woman and king and man have the same value along that first dimension. All this tells us is that these words have the same relationship along that dimension from the vector embeddings. It does not tell us what that dimension means, okay? It does not mean that a value of 0.3 corresponds to, some sort of gender or sex kind of characteristic, or that a value of 0.5 corresponds to a gender or sex characteristic. It just means that queen and woman mean the same thing, have the same meaning along this first axis, okay? So let's look at the math here. So basically what we're showing here is this idea that queen minus woman plus man is equal to king. So we'll take queen, which is 0.3, 0.9, and woman, which is 0.3, 0.4. And when we subtract them, we get 0, 0.5. And if you would like to venture a guess at what that means in the chat, I will tell you what I think that means later on. But if you would like to venture a guess on what you think maybe what word might correspond to 0, 0.5 in the chat, I would love to know. And if you take that and you add the word man, which is 0.5, 0.2, you will get 0.5, 0.7, which happens to correspond to king, right? So the idea of this slide, basically, the only thing you need to take away from this slide is vector embeddings let you do math on things that were not originally numbers. So Milvus lets us compare unstructured data at scale, right? This is what I was talking about earlier, all the different nodes, all the different ways you do search, that kind of stuff. Okay, so nobody has commented anything about what they think that this 0, 0.5 value means. So I will tell you what I think this means, and this doesn't necessarily mean what it is, but because we clearly can't see it marked here, but this would probably mean something like whatever the difference between queen and woman is in your hands, in your head. So probably something like royalty. Okay, so what about Mixtral? Oh, cool, someone said royal in the chat. Great job. Okay, what about Mixtral? What is Mixtral? So Mixtral is Le Big model. It is a big model from Mistral. So Mistral AI is based in Paris. So those of you who are from Paris, go say hi to them. And Mixtral is this kind of mixture of experts model. And so it's not just one LLM. It's essentially let's pretend like we have multiple LLMs. In this case, we have 8. And there's only 2 of them that are going to be activated at a time. And each of these LLMs is basically a Mistral 7B model. And Mixtral has this interesting, unique, unique at the time, no longer unique, but an interesting way to interact with language where it offers multiple languages that it understands: English, French, Italian, German, and Spanish. And if you think about it, it kind of makes sense, right? All of these languages have very similar roots. They're all from very similar areas. it makes sense that it's easy to get it's not easy, but let's say it makes sense that a model can understand these things. Okay, now what about Octo AI? Octo AI is our serving tool that we're going to use. So Octo AI provides a few different things. And the way that I think about it is basically generative AI as API endpoints. So most of us are probably familiar with how APIs work at this point, right? They've been around for a long time. In the beginning, and like when they first started coming out, we had like API gateways and all this stuff, and people were like, "Oh, what's an API? It's a black box, right?" You can think of it the same way, right? It's a black box. You send it a request, it sends you a response, and what it does in this case is it gives you the ability to use generative AI. So Octo AI has a few options you can use. You can use media gen, stable diffusion, or control net. You can use text gen, right? Mixtral, which we're going to use, Gemma, Smog, Llama. And it also lets you do compute with bring your own model. And so what we're really going to look at is we're going to look at text generation via Mixtral. And so there are 3 parameters that you can tune in this text generation. And these 3 that you probably, I mean, there's more than 3 parameters really, but the ones that you really want to think about here are the temperature, the top P, and the max tokens. And so temperature is basically, temperature and top P kind of do the same thing of how creative do you want this output to be? Temperature is more like how creative you want the output to be. Top P is how varied do you want the output to be, right? So LLMs are, you can think of LLMs as statistical models, right? And these kinds of, these 2 parameters tune the variation of the statistics of the statistical model behind the LLM. And there's max tokens, which just says like, hey, I only want you to do 200 tokens, 500 tokens, 1,000 tokens, whatever, right? We saw earlier, Mixtral has the ability to work with 32,000 tokens. We're not going to work with 32,000 tokens here. That's generally, more expensive if you have to do a lot of tokens. And so we get the ability to kind of adjust how many tokens we need. And also, this kind of restricts the LLM on how it should produce a response. Okay, so the last piece of this puzzle is LangChain. LangChain is the most popular LLM orchestration framework. And essentially the idea behind LangChain is you're going to chain a bunch of functions together. And one of these functions, or some of these functions, can be LLMs. You can treat LLMs as if they are a function. That is one of the core ideas behind LangChain. And LangChain has plugins with pretty much all the popular tools you can think of: Milvus, Octo AI, OpenAI, Milvus. And the idea behind this is that you're going to focus on these chaining all of these results together, which is why we call LangChain an orchestration framework. Okay, so now the next part of this is just the code demo. We're going to spin up the code demo and we're going to walk through the code. So
Hey,
if you
Eugen, before you
yes.
do, there was just one question I wanted to get answered from Nicolas. Is there a non-hosted alternative to Octo AI?
Is there a non-hosted alternative to Octo AI? Yes, you can host these models yourself. And actually, I'm working on something that kind of plays around with this using Bento ML. The other thing you can kind of do with this is you can go to Hugging Face, or you can go to, I don't know if Torch Hub has it. I think Torch Hub has some as well. But you can go to Hugging Face and you can download a LLM there. And depending on how much memory your GPU or CPU has, you can host an LLM directly from your GPU or your CPU. Locally, basically. And so that is a non-hosted alternative to Octo AI. Okay, so if you have enjoyed this presentation, I urge that you go and scan this code with your phone and go to the Milvus GitHub and give us a star. We'll be very happy about that. I see there's a couple other questions here, or one other question here that I'll answer, which is, how do you join the hackathon? My son was doing it in college. So you can join the hackathon by going to our events page, and you will see the hackathon posted there. And you can just, you have to be in Seattle for these hackathons, but you can just go and click join or RSVP. Cool. So I'm going to pull up my code. Aha. Great. So I'm going to zoom in just a little bit here. And we're going to also make this smaller. Okay. So this is a code sample of how you do what I was just talking about, which is building some sort of RAG app on top of Milvus, Mixtral, OctoAI, and LangChain. And so I've titled this MMO RAG, which just has a nicer ring to it than MMOL. But you know, it's like kind of, you think about like MMO RPGs. I was trying to make a joke here. So the first thing we need to do is we actually need to run Docker Compose. So I have Milvus running on Docker Compose, and we will have a link for you in the chat for how you can do that. But basically, once you have the Docker Compose file, you should just be able to run Docker Compose up-d, and it will start your what are they called? Containers. And now I have these running locally, and now I have a way to basically work with Milvus and have this kind of persistent storage outside of my notebook here. And so the first thing we're going to do, so this is a live example. Live examples are always a bit nerve-wracking, but let's hope this goes well. So here are all the pip packages that you'll need if you're going to be trying to run along with me. You'll need to get PyMilvus. You actually don't need Milvus. This is for Milvus Lite, but Milvus Lite can be run directly in your notebook, and you can also do that. And then you'll need LangChain, of course. You'll need sentence transformers to do the embeddings, and tick token. So this is for chunking. We'll talk about chunking when we get to it, but chunking is basically the way that you split up your data so that you can, access it in a reasonable manner. And then you'll need the OctoAI SDK if you're using OctoAI. If you are doing what I was talking about earlier with either Hugging Face, or if you're familiar with Bento, you can use either of those to run your LLM locally. So here in this first section, all we're going to do is we're going to get some imports from LangChain. So the first thing we're going to do is basically get the LLM chain, right? This is LangChain's core a piece of framework. Basically, the core thing that LangChain kind of runs on is like chaining LLM and LLM outputs together. And then we'll get the prompt template, right? Prompts are a very important way to work with your LLM. And basically, it's how you tell the LLM what to do. And then we're going to get OctoAI endpoints so we can use Mixtral from OctoAI. And then here, what I'm doing is I'm just loading my environment variables. You can load your environment variables however you want. I just prefer this method. And you can load your environment variables in this method and get the OctoAI API token. And then what we're going to do is we're going to make a template. And this is just an example template. So this is just something that we're going to use to basically ensure that Mixtral is working. And so basically all we're going to say here is below is an instruction that describes a task, write a response that appropriately completes the request, instruction, question, response, blah, blah, blah. Okay. And then we're going to turn that into a prompt template so that LangChain can understand this. And then what we're going to do is we're going to get our LLM. So from the LangChain OctoAI endpoint, what we're going to do is we're going to just say, hey, here's where we're going to ping. And here are some of the model keywords that we need. So in this case, we're using Mixtral's 8x7B, which is just their Mixtral model. And we're going to use the instruct version, which means that it takes instructions, it's fine-tuned to take instructions, not a general chat model. And we're going to use it in FP16. So FP16 is 16 bits. And classically, if you think about, if you're familiar with data types in programming languages, you're probably familiar with floats and doubles. Those are 64 bits, and those are typically what you would see vectors and models be using. But as we've kind of grown these models to these huge sizes, we've run into this issue of having models that are too big, and we've come up with ways to compress them without losing much of the performance. And one of those compression methods is to drop that down from double, which is FP64, to single, which is FP32, or half, which is FP16. And then we'll just say, hey, let's only use 128 tokens. Let's not run anything crazy. We're not going to do a very expensive test run here. And then we'll give it some sort of temperature and some sort of, ability to create, and then we'll give it some sort of prompt that tells it what it is. You are a helpful assistant. Keep your responses limited to one short paragraph if possible. And then we'll just give it a question. This is just a test, right? There's no RAG being done here. This is just using the LLM. Who was Leonardo da Vinci, right? And then we'll say, like, here's your prompt, here's the LLM, and then we're going to invoke that LLM chain, basically. And it should, oh boy, I didn't define prompt, did I? Uh-oh. Cool. Okay. So that worked. So I didn't run that cell above. So make sure you run all the cells. So this tells us that Leonardo da Vinci was an Italian polymath who's often regarded as one of the greatest painters in history, et cetera, et cetera, et cetera. Mona Lisa, blah, blah, blah. So basically this is like, yeah, Leonardo da Vinci is that guy. Oh, please provide a link to the code. Oh, yeah. So I can get that. GitHub. Talk to AI, Milvus. Okay, and where is the chat? There you go. That is the link to the code. Okay, so now we're going to start working with the RAG portion. And so for RAG, we're going to need to do embeddings, and we're going to need a vector database. And so we're going to use the OctoAI embedding endpoint from LangChain and Milvus as a vector store from LangChain. And basically, this part, the embeddings endpoint, is pretty simple. We just give it the embeddings endpoint, and this creates, and LangChain creates an embeddings function out of it. And for the next part, what we're going to do is we're going to do a little bit of document manipulation. So in the repo that I sent, this is the repo will just give you, or sorry, the link that I sent is just the notebook. But if you go outside of the notebook, you'll go to the repo. And in the repo at large, you'll see that there is a data folder, and we're going to work with that data folder. So here, all we're doing is importing the character text splitter, which is one way that you can split your data into chunks, and then the document, which is the way that LangChain deals with documents, and OS, which is, your operating system. So the first thing we'll do here is we'll just get a list of all of the pieces of our, all of the data that we're going to be working with, and I'll just print this out for you so you know what we're seeing here. Excuse me. Okay. So we have a bunch of text documents from Chicago, Washington, D.C., Cambridge, Massachusetts, Houston, Seattle, Toronto, San Francisco, and Boston. And basically, these are the cities that we're going to be working with. These are straight from Wikipedia, just straight out of Wikipedia. And what we're going to do is we're going to get these files and we're going to put them into a text chunker. So I wrote this function. I was hoping to find a very easy way to do this with LangChain, but I couldn't find it. So if you find an easier way to do this with LangChain, I'm very interested in knowing. So please send that over to me if you find it. So basically, all we're going to do is we're going to loop through all of these files. We're going to open the file. We're going to read the file. So now we have the file text as a string. And then we're going to create a text splitter. So LangChain has the ability to split on texts. And so we're going to create a text splitter that's going to use tick tokens encoder. And we're going to just say, let's say a chunk size of 512 with an overlap of 64. So chunk size and chunk overlap are definitely things that you should consider when you're working with your data. This is how you get your data into a reasonable format to work with, right? And what chunk size and overlap mean in this case is basically how many characters are we going to be dealing with. So if you think about it, 512 characters is about 100 words. It's maybe a paragraph or so, maybe like a paragraph to a paragraph and a half. 64 is like about a sentence, right? So basically what we're saying here is we're going to chunk up our data into these paragraphs. And between these paragraphs, we're going to make sure they overlap by about a sentence so that when we get these documents, we'll see where the overlap is, and we'll be able to kind of, without being able to see exactly what the chunks would look like, we'll be able to programmatically guarantee that we'll have some sort of context overlap in between each of our chunks, right? So context is very important for, for your data, basically. So now that we have this text splitter, what we're going to do is we're going to take the texts and we're going to run this text splitter on the string of the entire data that we just read in. And then what we're going to do is we're going to go and I'm going to enumerate through that list of texts. So I'm going to turn that, I'm going to get both the position of the text as well as the text itself. And basically I'm going to append that as a document, which is how LangChain understands these entries. And I'm going to append that as a document. And I'm going to say that here's the data, and here's the title of the file, like where is this data from. So you'll see that this is actually done pretty naively, and that Washington DC will actually give us Washington D, but everything else will work. So this is kind of interesting. And then we'll say here's a chunk number. And so hopefully, did I run this one? I did. Okay. So this should run some text chunks, and it'll tell us, hey, so some of the chunks are longer than specified, but that's based on like the tick token character encoder to understand that, hey, sometimes we want complete sentences, so maybe sometimes we need a longer chunk than specified. Okay, so now what we want to do is we want to put these chunks of data into Milvus. So I'm going to run this because this will usually take at least 20 seconds or so. And basically what we're doing here is we're saying we're going to create a collection in Milvus. Collections are kind of like tables. And we're going to create this from this document set, right? So that's why these are called documents. We're going to create this from this document set. And the document set that we're going to use is this list of file texts. And then we're going to use this embeddings function, because vector databases, vector stores, they store embeddings. And so we need to give it an embeddings function so that this function can turn all of this text, all of the page content, basically. You'll notice that here, there's this thing called page content, all of the page content into embeddings. And that's the function that does it. So that was the OctoAI embeddings function that we did with. And by the way, that is GTE large. That's the models being used. And then we just need some connection arguments. And so I have Milvus running on Docker Compose locally. And so the host is just localhost. This can also be 127.0.0.1. And then the port, we use 19530. And then the name of the collection is just going to be cities. Okay. And now we're going to take a look at what one of these file texts look like. So basically document page context equals Chicago, et cetera, et cetera, et cetera. So Chicago is the first one that's read in. This is what it looks like. It looks like someone sent something in the chat to do the text splitters. Okay, cool. I'll have to try that out. Thanks, Max. Okay, and now what we need to do is we need to be able to use this vector store. Now we have a storage where we have a place where all these vectors are being stored. Now we have to be able to use them. So what we do is we turn this into something called a retriever. And the retriever basically just gives you a way to query the vector store, right? Retrieve data from the vector store. And then we'll create another prompt, another template and another prompt, right? So the template this time is we'll say, answer the question based only on the following context, right? And this context is going to be the context that we grab from the vector database. And then we're also going to give it a question, and we're going to say, and we're going to turn it into a prompt template. Okay. So now we're going to create the LangChain chain. So this is the part of LangChain where it really shines, and we're creating a chain out of LangChain. And so the things that we're going to get here are a runnable pass-through, which basically lets you just pass through some text as a function, and then a string output parser, which parses the output as a string. And then we'll create a chain where we give it the context, and the context is going to be from the retriever that we made earlier. And the question is basically going to be done through the runnable pass-through. It's basically just going to be given directly. And then we'll say, here's the prompt. Remember, the prompt is this prompt right here. And then we'll pass that prompt to the LLM, right? This is the pipe, just like CLIs, right? And then we'll pipe that to the string output parser so we can parse the output of the LLM as a string. And then we'll ask something. Let's ask, how big is the city of Seattle? So big is kind of, you'll see this in a second. So this is interesting. Big is kind of a weird term because it could mean the population size, or it could mean the area of the city. And you'll see here, and Boston, the answer for Boston was the population size, but the area of the city is, the answer for Boston was the area of the city, but the answer for Seattle here is the population size, and maybe it does give the answer to the city as well. Oh, yes. No. It just gives the population size. So maybe we can also ask, like, how many square miles is the city of Seattle? And it'll give us like the, well, I guess it doesn't provide the information. So, that's very interesting. I guess Wikipedia doesn't have that, or if it does, we were unable to convey that to Mixtral. Okay, so one of the other things that we can do is we can do something much more interesting. Let's actually leverage one of the interesting or unique, points about Mixtral, which is its multilinguality, right? It's able to work with multiple languages. And since Mistral is based out of Paris, we're going to ask it to do French. And your helpful assistant who responds in French and not English, and answer the question in French based only on the following context. And you'll see basically what I did was I copied and pasted the original portion, and then I just attached the word French in front of everything so that we can get the French ones. And the French chain will basically use the French prompt and the French LLM. And then we'll ask how big is the city of Seattle. And the French LLM will give the French chain will call the French LLM, and it will ask the question and get it to respond in French. And now the response in French is basically the same as the response in English. Now, I don't actually read French, but I'm pretty sure this says the city of Seattle has a population of 750,000 inhabitants in 2022. And the metropolitan region of Seattle composes 4.02 million inhabitants. I don't know what this is saying, honestly. Something growth at 21.1% a year, something like that. Can sentence transformer be used as an embedding tool? Yes, it can. And in fact, I would say that Hugging Face's sentence transformers library, which we did import earlier, is my favorite embedding tool because it's free and you can host it locally and it's easy to use. So the answer is yes. And you can also use a bunch of different models on it. It's just like, since we're doing everything hosted, I just figured I would pass this on to the hosted version. Cool, no open questions. Which makes it the 15th biggest. Oh, thank you, Damien. Yes. The 15th biggest. Yes, which makes it the 15th biggest metropolitan region in the United States. And then something about growth rates. And so that's it. That is how you can build a RAG app without using OpenAI. And if you would like, we can also ask the French chain some other questions and get some other responses back in French. So I'll kind of open the floor for people to put some different questions down, and we can try to ask it some different questions and see if we get something interesting. You can translate French to English. I can't translate French to English, but maybe other people can. I've noticed ChatGPT can translate to a few speaking languages. Is that recommended, or is there a specific translation mode? I mean, so this is a good question, but or this is a good point. So I've actually played around with this a little bit more, and you can actually ask questions in multiple languages and get back responses in multiple languages. And it's not just French, German, Italian, Spanish, and English like advertised. You can actually play around with like Hungarian or Turkish or other languages like that as well. But I think like there's I have no real insight into why you can do that. And the only response that I really have for this is, hey, LLMs are magic. Sufficiently advanced technology is indistinguishable from magic. How does it work if tokenization is different for different languages? Yeah, see, I want to know that. I want to know that too. That's a great question. And unfortunately, I just don't know.
Well, you can ask the Mistral people.
I could ask the Mistral people. So I know that Mistral actually has one of their experts, they're in their mixture of experts is basically this translation kind of thing.
Is there like a evaluation of the correctness of the translations? Is there something like that?
There isn't, at least not widely known. You basically just have to find someone who understands French. So I was building this with Thierry, and Thierry speaks French. And so he was like, yes, this is, what it is. And so I was like, cool. Does LLM treat latest index with a higher weight? Does the LLM treat the latest index with a higher weight? I'm not sure I understand the question. Can you expand a little bit about what higher weight means? Or sorry, what the latest index might mean? Take the output of the French and ask the model to translate to English. Oh, that's a great idea.
Oh, that's a good idea.
That's brilliant. Okay, so let's do chain.invoke translate to English. And so we're gonna okay, wait. So let's go back and let's go back and reinstate one of the old ones. Let's just get it to this. So we'll do question. No, we'll get rid of this and we'll just say like English chain prompt equals prompt. So prompt will be, let's see what that says up there. Where'd it go? Where'd it go? Oh, here it is. Below is an instruction that describes a task. Write a response that completely, okay. Let's say translate the entry into English. Entry. And then what we can do is question or entry equals, oh, whoops, let's copy and paste this. Ah, maybe if I just do what's FR1. Okay, let's just do entry equals FR1 then. FR1 is not defined. Are you serious? Did I just type this wrong? Oh, FR_1. Oh, yes, okay. Okay, so let's see what it says. Let's see if it translates the entry into English or if I try to, thank you for the information about Seattle's population. To summarize, Seattle had a population of approximately, okay, so yes, this basically translates it into English. And yes, between 2010 and 2020, Seattle experienced a notable growth of 21.1%, ranking it among the fastest growing cities in the country. These statistics highlight Seattle's increasing importance in the national landscape. Yeah, that's right. So if you live in the US, you should come to Seattle and come to all my AI events. Okay. How are the embeddings stored in VectorDB adding to the value of the response we were seeing in the LM? Can you show with the sample? Basically, what difference would the response look like if we didn't? Well, as we saw earlier, if the embedding is not in the VectorDB, then it cannot answer the question. So that is this is the answer to your question about having the embeddings in the vector database.
Does that answer your question, Angel?
Awesome.
I mean, I guess, we have to remember that, yes, these models are large, but it doesn't have like every single answer, at least not now.
I actually think like with some examples it's easier to show than others, but in this case, like one of the things is because this is an instruct model, it is fine-tuned specifically to follow the given instructions, which means that even if the model has the answer, it won't answer it if the context is not given from the vector database. So I'm actually pretty sure that like theoretically, like Mistral should know how, it should know like how big the city of Seattle is. But because we don't have the answer stored in the vector database and it is an instruction tuned model and we do not provide that context, it says that, hey, I don't have that information. so I can't answer your question. If I can't find it in my data, is there a way to allow the LLM to find it for me? So I assume this is kind of a follow-up to Angel's question. And like I think I was just talking about this. So the answer is yes. Yes, you can. And there are two ways that you can do that. One is you can just rely on the LLM's training data, which may or may not be true and may or may not be up to date. Or two is you can build an agent that will go and scrape the web for you. And conveniently, I recently built an agent and published a blog with a tutorial on it. And so we can drop that link in the chat for you. Which vector DB can cater to financial data? Well, I think the thing with financial data is that you care a lot about security and privacy and
latency, probably.
probably latency. And so what you probably need is something that you're going to deploy yourself on premises. You don't want to send any data around. So you should use Milvus and you should deploy it on Docker and you should put it into the same VPC as everything else you're doing. And
But
can...
even financial data, there's like specific use cases underneath it that, you know, you also have to think about, right?
Yes, yes. So it could be like, you know, like evaluating whether or not someone is qualified for a mortgage, or it could be like, you know, predicting the stock market. And these are two use cases that are kind of different with different sensitivities. But either way, you know, probably want to deploy something on-prem. And so Milvus is open source, permissible, you can do that.
Or if you're trying to find anomalies, then you definitely want to make sure that you have, you know, very strong consistency, right? That's going to be more important because you're going to want to make sure you look at all the data.
Yes, yes. And oh, that gives me a perfect segue to talk about the consistency levels in Milvus. So Milvus is a distributed system, which means it has instances and replicas. And Milvus has 4 levels of consistency that you can do. And so with financial data, you probably want the strongest level of consistency called strong consistency, which guarantees that everything is read after write. Can you give more weights to some chunks or documents in the vector DB for prioritized retrieval? You can. So what you can do is you can do this manually. You can basically give it like a metadata that tells it, you know, like, hey, here's the weight. And then what you can do is you can re-rank things by the weight that they get. You can retrieve extra information and re-rank by weight. Or you can just simply filter out some of the weights. You can say, hey, this is not something I find very important, so I don't need to in this particular query. So that's one way you can do this.
Is that some chunks per document that he was asking, or just overall chunks or documents?
It says chunks/documents, so I'm going to guess both.
I was just wondering that if that new group search can also kind of help too, because I think you might be able to do something with that as well.
Group by, yes. I don't know if there's a feature to see how many chunks are relevant via group by, but group by will let you basically just search documents and not chunks, which is really nice if you want to get unique documents back. And maybe you can kind of do something similar where you use group by and also see like how many chunks are getting thrown out, which tells you like how much of the document is relevant to your question. That was an easy thing to translate. Try the bat broke along the handle, translate to French, and then back to English. I think we'll take this on offline. Let me answer the other questions first. I don't want my intern to see the CFO data. How do I control that in a RAG system? You know, that's a really good question. And that is actually a particular question this question is particularly relevant to enterprises. And, you know, I gotta say, Milvus has this thing called role-based access control. And that is probably how you would do that. You would say, hey, interns don't get to see the CFO data, but the CFO can see the intern data. That's probably something that you would want to do through Milvus. Can you factor in time in the queries? I think so. I'm not entirely sure I understand the question. Perhaps if you want to say like, hey, I only want to get queries with context after a certain time, then that's when you would like, remember I showed the data, like I showed like the publication date, like you could say like only show data after this publication date. You can use hybrid search or metadata filtering, whatever, to do that. So I think the answer is yes, if I understand the question correctly.
Well, he's got a subsequent. Martin has a little more info.
Oh yes, if I have RAG, I want newer data to be more relevant. So yes, basically you can filter on the newer data. You can also give them, dynamic weights based on how new the data is. You can say like, hey, like I want to know like, it has to be published within the last 30 days, within the last 10 days, within the last 10 hours, whatever. And so yes, you can do that. It just requires a little bit more tuning. And the question in news, can latest news be treated with more relevance? The answer is the exact same to the one I just gave. Yes, it just requires a little bit more tuning.
You have the incremental index build.
Yes, can Milvus do incremental index build without need to rebuild index every time we add new, say, daily portion of data? So this is exactly what I was saying. Milvus doesn't need to rebuild the index. You just build index on the new data, and then you can search, and the new data and the old data will be searched. And if you want to delete data or upsert data, it deletes it out of the old segments, and you can get it into the new segments, and it can be searched at the same time. So the answer is yes, and that's actually how it's done automatically. How can I do a bulk insert into Milvus or copy a DB from another install? So Milvus just recently added Parquet, so you can export your data into a Parquet file and you can insert it into Milvus. And in this way, you actually get to skip the log, the write-ahead log, the pub subsystem, and it just publishes the data directly into Milvus and creates the indexes on that as you enter your data.
Also, there's a Milvus backup, right? You could do it that way too.
Yes, there's also a way to do Milvus backup. What is the best way to structure and store chunks for efficient vector retrieval? Wow, this is a really good question. And the answer is nobody knows. So this is something that you're going to have to test, and it's going to be based on the way that your data looks like. So for example, if your data is time sensitive, you're going to want to include publication dates or how long, or how long ago it was published or things like that. And if your data is very long and it's in the document form, you're going to want these chunks of data that are paragraph sized. If your data is in conversational form, you're going to be able to want to split up your data and just have different sentences in there, right? So there are many ways to structure this and to store the chunks, and it really just all depends on what your data looks like and what you need to do with it.
You have a bunch of questions in the chat too.
Oh, Milvus has good ACLs for financial data too, but you probably need encryption and a local install. Yep. And precision. Okay, wait. Did you mention a link to a chatbot? Can you share? I think I mentioned the link to this repo, and it is in the chat, and I will share it again. Okay. And here is the repo that this is in. What is the max batch size Milvus supports during batch insertion of vectors? Is it scalable based on system network requirements? So yes, it's going to be based on your system network requirements, and it's going to be dependent on how large your CPU is, how fast it is, which CPUs you're using, how many instances you have, all of these different things. But as far as I know, yeah, you can insert gigabytes at a time if you want. How large can Milvus grow? Milvus is basically meant to be very, very big. And it has more than 50 projects with over 1 billion vectors in production. And I mean, it can grow as large as you want, basically, as long as you have the hardware and the DevOps to support it, it's pretty much indefinite. How would I put this on a website for people to use who can't work with this code-based interface?
Actually, there's we have a user or a company that actually built a kind of point and clicky way of building a chatbot. They're called Mind Studio. So I would take a look at theirs. So they built it so that non-developers can build chatbots. They have a pretty good UI. So check out how they're doing it.
Yep. So there's that. How large can Milvus grow? Yep, I just addressed this one. Can Milvus store tabular data? So Milvus stores data basically in JSON format. So if you put your if you take your tabular data, I mean, I think tabular data can be represented in JSON format. So my answer to you is yes, you just have to transform it into the right format.
Wow, that was a lot of questions, Eugen.
Yes, it was.
So here we got one more.
Okay, we'll take one more question before we go. How to convert the information from a relational DB to a vector DB by splitting it to an embedding part and its metadata part automatically. So you actually have to write the pipeline for that. No, we have Zill's pipelines, right? Zill's pipelines can probably do something like this, where as long as you pull the data out of your vector DB, you can just run it through Zill's pipelines, and that will go, well, that goes into Zill's cloud, but essentially you can do that and put it into a vector DB, and it will do it automatically for you.
And there's, I think, 6 models right now that's supported. So
yeah, there's a lot of models.
And it's free still. So try it while it's still free. Cool. I think we got all the questions. So if anybody has any more questions, hit Eugen up in the Discord channel, or his favorite is LinkedIn. He's always there. So you can always like pop some questions in there.
Always on
And yeah, come join us at one of the meetups. Come join Eugen at one of his hackathons if you're in Seattle. Definitely go and see him. He's also known as the guy with the hot pink pants. So he wears these pink sweatpants, so you can find him really easily. And if you have any other ideas for content that you want us to create, just let us know. And we're happy to be able to build that so that you guys can all start building really cool solutions. Awesome. Recording will be sent once Ms. Sachi, who's on the call with us, does her final edits, and she'll send the link to everyone. And we'll make sure that you get also the link to the repo as well, so you can play around with it. And if you have any other ideas for that notebook, just let Eugen know.
Cool.
All right, folks, have a great day.